Hello, cloud adventurers. Welcome back to Nimbus Nebula, where the clouds become your innovation playground. I'm Cloud Architect Pro, and today we're diving into a game changer: proactive controls in AWS Control Tower. In our last episode, we uncovered the power of detective controls, the vigilant guardians spotting non-compliance in your cloud environment. Today, we're leveling up to proactive controls, the ultimate enforcers that block non-compliance before it happens. Think of them as your preemptive strike, ensuring every resource deployment is secure and compliant right from the start. Ready to dive in? Let's go. What are proactive controls? Picture this. Your developers are deploying resources when a gatekeeper steps in and says, "Stop, does this meet our security standards?" That's exactly what proactive controls do: block non-compliant resources before they're provisioned. Think of them as the Gandalf of CloudFormation. You shall not pass unless you're compliant. For example, proactive controls can enforce HTTPS-only requests for S3 buckets, aligning with PCI DSS standards for secure data transmission. No encryption, no deployment. Why do they matter? In the cloud, prevention is better than cure. Proactive controls are your first line of defense, ensuring every resource meets compliance standards before deployment. Excited to see them in action? Let's make it happen. Your mission briefing. Before you can activate proactive controls, you'll need a few prerequisites. AWS Control Tower Landing Zone version 3.0. A sandbox OU with an active account. We'll use test account 1. The preventive control ct.cloudformation.pr1 deployed. Without these, you're like a superhero without their powers. We already have the Control Tower Landing Zone and Sandbox OU in place. Now let's deploy ct.cloudformation.pr1. Deployment steps: log into your AWS Management Console and go to the Control Tower service. Navigate to the Controls library and choose All Controls. In the Find Control box, search for ct.cloudformation.pr.1. Select it. Click Control Actions and then click Enable. Select the Sandbox OU and click Enable Controls. Now we have successfully enabled the preventive control ct.cloudformation.pr.1. Now, let's get started by locating and enabling the proactive control ct.s3.pr. This control ensures that all S3 buckets are configured to require Secure Socket Layer (SSL) for secure connections. While still in the Control Tower console, navigate to the Categories section in the Controls library. Switch to the Frameworks tab and select PCI DSS version 3, 2.1. In the Find Control search box, click Service. Set the filter to equals and select Amazon S3. Then in the Find Control search box again, click Control Objective. Set the filter to equals and select Encrypt Data in Transit. You can find the control ct.s3.pr. 8. Require that Amazon S3 buckets request to use Secure Socket Layer. Before enabling the control, understanding its implementation is essential. Navigate to the Artifacts tab where you'll see 3 associated artifacts. Let's review each one. CloudFormation Guard Rule. This artifact enforces SSL for Amazon S3 bucket requests, ensuring secure data transmission and compliance. Written in Gherkin syntax, it's machine-readable and human-friendly. The rule validates S3 bucket configurations in CloudFormation templates, requiring a defined policy document attribute. A policy statement that blocks all S3 actions S3** when the connection is not secure, that is, AWS Secure Transport is set to false. Non-compliant AWS CloudFormation template example. This template fails to comply as it allows unsecured requests. Issue: the policy document includes a statement with effect: allow for all actions when AWS Secure Transport is false. Why it fails: this setting permits non-SSL requests, violating the guard rule. Compliant AWS CloudFormation template example. This modified template meets the guard rule. Change: line 18 is updated to effect deny, blocking all actions when AWS Secure Transport is false. Why it passes: Denying unsecured requests enforces SSL TLS for secure bucket access. The key difference is in line 18, where effect allow is changed to effect deny, effectively blocking unsecured requests. Click the Enable Control button at the top right of the screen. Select the radio button next to the Sandbox OU and click Enable Control on OU. Go to the OU's Enabled tab. The status will show as enabling, which may take a few minutes to process. Once enabled, the status will change to enabled next to the applicable OU. Navigate to the Organization section. Open the Sandbox OU. Scroll to the Controls section and enter the name of the control we enabled into the search box. ct.s3.pr. 8. Require that Amazon S3 buckets request to use secure socket layer. You should see that the status for the current OU is marked as enabled. Now that the control is enabled, let's verify that it's working as expected. To do this, we will inspect the AWS CloudFormation hooks. AWS CloudFormation hooks is a feature that allows you to run custom code to inspect the configuration of AWS resources before they are provisioned. If any resources are found to be non-compliant, the CloudFormation hook returns a failure status. Depending on the failure mode set for the hook, it can either fail the entire operation or provide a warning and allow the operation to continue. By leveraging CloudFormation hooks, you can enforce compliance and prevent the deployment of non-compliant resources. Let's see it in action. Switch to the Sandbox account, test account 1. Open the CloudFormation console. Go to the Hooks tab and locate the AWS Control Tower hook. Click on it. Inspect the hook configuration. See the description, AWS Control Tower hook for proactive controls. Also verify the hook status is enabled. Now check the hook parameters section. Check the controls to apply field lists, the required controls such as ct.s3.pr. 8, which ensures that S3 buckets enforce SSL encryption. Now expand the hook filters. Confirm that the target resource types are correctly set to the relevant types such as AWS, S3, bucket policy. This corresponds to our proactive control because it will check that all S3 buckets have a policy that requires encryption in transit. Now let's test using a non-compliant CloudFormation template. I have the template stored on my local machine and will use it to deploy an S3 bucket with a bucket policy that permits both HTTP and HTTPS requests, failing to enforce SSL. After deployment, we'll investigate the resulting validation errors. In the CloudFormation console, navigate to the Stack section. Click Create Stack and select with New Resources Standard from the drop-down menu. Under Specify Template, choose Upload a template file. Click Choose File. Then upload the template file. Once the template is uploaded, click Next. Enter MyLog Bucket Stack as the stack name. Click Next to proceed without making changes. On the next page, leave the settings as default and click Next. Review your stack configuration and click Submit to begin the deployment process. The stack status will initially show create_in_progress. After approximately 1 minute, the deployment will fail and the status will change to rollback_complete. Now it's time to troubleshoot the failure. Open the Stack's Events tab to see why it failed. The error log will reveal the AWS Control Tower hook was invoked. The S3 bucket policy violated the guard rule. Deploy a compliant template. Now let's fix our mistakes. I've saved the compliant YAML template cfn-compliant.yml on my local machine. This template blocks insecure access for all users and entities, ensuring adherence to secure transport requirements. We're ready to deploy this template, but first we need to delete the failed stack MyLog bucket stack. Once deleted, we'll redeploy using the compliant template via Create Stack with the New Resources standard option. Let's wait for the deployment to complete. Now that the deployment is complete, let's verify the stack. It shows a status of create_complete. Validation. Open the Resources tab and choose the AWS S3 bucket resource that was created. This will bring you to the S3 console to view the bucket details. Choose the Permissions tab and scroll down to Bucket Policy. Notice the bucket policy that we applied is depicted here, and that requests will be denied if AWS secure transport. False. Congratulations, you're now a proactive controls master. Let's clean up and reset the environment. Now it's time to disable the proactive control ct.s3.pr. 8. Switch back to the management account and open the Control Tower Service Console. Navigate to the organization. Open the Sandbox OU. Scroll down to the Controls section and paste the name of the control that we previously enabled into the search box, ct.s3.pr. 8. Click on the control name to open the control details. Select the radio button next to the Sandbox OU and hit Disable Control. After a short period, the control will be removed from the OU and you will see a verification message at the top of the dashboard. Now let's disable the prerequisite preventive control. Open the Control Tower console in the Management account. Navigate to the Controls library and locate ct.cloudformation.pr1. Disable this control on the Sandbox OU. Delete Resources switch to the Sandbox account. In the CloudFormation console, delete the MyLog bucket stack. With proactive controls, you now have the power to block non-compliant resources at the gate, validate and troubleshoot deployment failures with ease. Keep your environment clean and compliant. That's it for today's episode. Episode 5 drops next week. Don't miss it. If you found this helpful, make sure to like, subscribe, and hit that bell to stay updated with more AWS awesomeness. This is Cloud Architect Pro signing off. Until next time, stay proactive and keep building securely.